Multiple independent instrumental datasets show that the climate system is warming. The 2011 to 2020 decade warmed to an average 1.09 degrees C. 0.95 to 1.20 degrees Celsius. Compared to the pre-industrial baseline. 1850 to 1900. Surface temperatures are rising by about 0.2 degrees Celsius per decade, with 2020 reaching a temperature of 1.2 degrees Celsius above the pre-industrial era. Since 1950, the number of cold days and nights has decreased, and the number of warm days and nights has increased. There was little net warming between the 18th century and the mid-19th century. Climate information for that period comes from climate proxies, such as trees and ice cores. Thermometer records began to provide global coverage around 1850. Historical patterns of warming and cooling, like the medieval warm period and the Little Ice Age, did not occur at the same time across different regions. Temperatures may have reached as high as those of the late 20th century in a limited set of regions. There have been prehistorical episodes of global warming, such as the Paleocene-Eocene thermal maximum. However, the modern observed rise in temperature and CO2 concentrations has been so rapid that even abrupt geophysical events in Earth's history do not approach current rates. Evidence of warming from air temperature measurements are reinforced with a wide range of other observations. For example, changes to the natural water cycle have been predicted and observed, such as an increase in the frequency and intensity of heavy precipitation, melting of snow and land ice, and increased atmospheric humidity. Flora and fauna are also behaving in a manner consistent with warming. For instance, plants are flowering earlier in spring. Another key indicator is the cooling of the upper atmosphere, which demonstrates that greenhouse gases are trapping heat near the Earth's surface and preventing it from radiating into space. Regions of the world warm at differing rates. The pattern is independent of where greenhouse gases are emitted, because the gases persist long enough to diffuse across the planet. Since the pre-industrial period, the average surface temperature over land regions has increased almost twice as fast as the global average surface temperature. This is because of the larger heat capacity of oceans, and because oceans lose more heat by evaporation. The thermal energy in the global climate system has grown with only brief pauses since at least 1970. And over 90% of this extra energy has been stored in the ocean. The rest has heated the atmosphere, melted ice, and warmed the continents. The Northern Hemisphere and the North Pole have warmed much faster than the South Pole and Southern Hemisphere. The Northern Hemisphere not only has much more land, but also more seasonal snow cover and sea ice. As these surfaces flip from reflecting a lot of light to being dark after the ice has melted, they start absorbing more heat. Local black carbon deposits on snow and ice also contribute to Arctic warming. Arctic temperatures are increasing at over twice the rate of the rest of the world. Melting of glaciers and ice sheets in the Arctic disrupts ocean circulation, including a weakened Gulf Stream, further changing the climate.